if we have a compound that has more than two elements, element symbols always start with a capital letter, and if there's a second letter or a third letter, there's lowercase letters, so there's three capital letters, must be three elements. If there are three elements, the first thing you want to do is to find a polyatomic ion, or at least attempt to try to find a polyatomic ion that matches part of the formula. There is a polyatomic ion that is Cl and O, and that's a hypochlorite ion. Okay. So, yeah, we're getting there. I'm explaining how to name it. So if it's an H on the front, okay, that means it's more than likely an acid. We're going to use acid naming rules. Okay. We're going to start by naming it like an ionic compound. So this would be, in ionic compound form, is hydrogen, hypochlorite. When we have an acid name, or we have an acid name with an "ite" ending, we're going to change that to OUS. When we have an acid with a polyatomic ion, we're going to drop the word hydrogen off the front entirely. So this becomes hypochlorous acid. They didn't write the word acid?
Yeah, but I did like the other part
Okay.
right.
Well, let's go through a naming system here then, okay? So, the hypochlor, that's something that you have to have. Let's see, how many different problems do we have? We have 1, 2, 3, 4, 5. Let's say that the hypochlor part is worth 5 points. The suffix OUS is worth 5 points. And the word acid is worth 5 points. Okay? Alright, so, well, I did it there, it's fine. Okay, so the next one we had to do then was this one, HBRO2. That was number 1. Number 2, HBRO sub 2. So we're going to look for a polyatomic ion again here. And BRO2, there it is right there, bromide ion. Okay. So we name this, like if we're naming it like an ionic compound first, and that's the rule. We start out with hydrogen bromite. And when we name this or change it to be the name of an acid, since we have a polyatomic ion, this is an oxyacid, we're going to drop the hydrogen off the front. Again, we're changing ite to OUS. We're putting acid on the end of the name. So this is called bromous acid. Alright, so the next question then was to write these formulas. So we have nitric acid. So nitric acid, if I have no hypo on the front, this must contain a polyatomic ion, or it's an oxyacid. So we're going to look for a polyatomic ion that has an NRI or NITR, and the IC ending came from ATE. So we're looking for a nitrate ion. Okay, and we're going to put hydrogens on the front to make an acid. So we got to have H plus, and we need a nitrate ion. Nitrate is NO3 with a 1 negative charge. Okay, so the IC ending either comes from an IDE ending if I have a hydro on the front. I don't have the hydro on the front, so now the IC ending must come from a polyatomic ion with an 8 ending. So we've got a nitrate ion. If you want to deconstruct using the name first, you might deconstruct it by calling it hydrogen nitrate, and then write the formula, which is perfectly okay. You can do that either way, as long as you get to the right answer in the end. All right, so we have a 1 plus charge here and a 1 negative charge here. We only need one of each of these to make a 0 charge. Yes. What now? Sinus. S-I-N-U-S. Okay, so we just need one in one of those. So the formula then is HNO sub 3. There's your answer right there. Okay. So let's see. Let's keep up with the naming systems. BROM here is going to be worth 5 points. OUS 5 points. Acid on the end 5 points. Here, let's see. I guess we're just going to give the H part 5 points and the NO3 part 5 points. All right, so number 4 was to do the formula for sulfurous acid.
Wait, why should I hypo front
Here?
Yeah.
Because hypo is a prefix reserved for binary acids. And that's not a binary acid, that's an oxyacid. Binary acids only have 2 elements. This one has 3. Alright, so 4 we're supposed to name, write the formula for sulfurous acid. Okay. That OUS prefix means I must have had a polyatomic ion with an IT ending. I'm looking for a polyatomic ion with an IT ending and an SULFUR prefix, or in this case, since we dropped the UR to make this polyatomic ion, it's SULF. So we're looking for a sulfite ion. Okay? And since it's an acid, we're going to have hydrogen on the front. So the formula, or the name of the formula, if we're naming it like an ionic compound, then should be hydrogen sulfite. So we're going to have hydrogen ions, and we need to find the sulfite ion. On your common ions list, sulfite is listed right here. SO3 2 negative, that's sulfite. So we need to find a balanced formula for this. We have a 1 plus charge on this hydrogen ion. We have a 2 negative charge on this sulfite ion. We need our equation on the charges. This is just an equation for balancing out charges to equal 0. So I need 2 of these and 1 of these. Therefore, I'm going to need 2 hydrogen ions. Then when I write the formula, when I bond the hydrogen ions and the sulfite ions together, it becomes H sub 2 SO sub 3. So that's our final formula there for sulfurous acid. So we're going to give 5 points to the H. I'm going to give 5 points to the subscript 2 here. And we're going to give 5 points to the sulfite ion, SO3. Question number 5 on the homework. Write the structural formulas, all the structural formulas for butane. Butane.
You said write all of them?
That's 4.
That's what it says.
Oh.
Write all the structural formulas for butane. Now that would be all the structural formulas we've covered in class so far. There's still a couple. Let's see. Actually, there's one more we really haven't covered. So structural formulas for butane. Okay, so butane, the prefix but means 4 carbons. Okay? So I'm going to start with doing this. Carbon to carbon to carbon to carbon. I'm going to put hydrogens here all the way around. And that's one of the structural formulas. Another structural formula would take and replace any shared pairs with single lines.
So we only have to do one.
No, it says all the structural formulas. The question said, write all the structural formulas for butane.
All is underlined.
So all you saying is 4 to
H. We're going to replace that set of double, or that shared pair there with a line. Replace this shared pair with a line. Replace this shared pair with a line. And this shared pair with a line. And that shared pair with a line, and so forth. Every shared pair gets replaced with a line.
Why don't you actually show them like joining together?
What do you mean? Oh, I didn't say you had to show the sharing arrangement. So I'm not going to give credit for that, even though that's probably the best place to start. Okay?
The structural formulas are just like that.
Yeah, these are the structural formulas. Okay? And so what she's asking, why didn't I show the sharing arrangement, the way that we learned to put together Lewis formulas in the very beginning? And that's because I asked for the structural formulas, and that's really how you set it up, not really the structural formula itself. So this is the second structural formula. Okay? And then the third structural formula I taught you takes each of the carbon-hydrogen groupings. So that would be, this would be a carbon-hydrogen grouping here. This is a second carbon-hydrogen grouping here. And a third and a fourth carbon-hydrogen grouping here. So when we write this formula, we're going to write CH3. And this one is CH2. And this one is also CH2. And then we got CH3 on the end. Okay? And those are the 3 structural formulas.
So you just circle one C, basically, on the little structural thing.
You don't have to circle anything. I'm just showing you where I got this from. That's just to show you where I got this from.
Yeah, that's what I'm saying. Like, never mind.
I'm saying you write this part of the formula from this grouping right here. You don't have to circle anything. That's not required. All that's required is the red part here.
It helps.
Well, it does help. I think so. That's why I show it to you that way. All right? Let's give each of these formulas 5 points each. Okay? 15 points for the total. That's right. So question number 1 is worth a total of 15. And question number 2 is worth a total of 15. Question number 3 is worth a total of 10. Question 4 is 15. Question 5 is 15. So let's see, that would be 70 points total for everything, right?